Hello guys, so today's video is about P0088 and P0087. This video is specifically for territory diesel SC, but it's still largely applicable to any closed loop diesel fuel system. For example, I was looking at one of the Volkswagen systems, and it looked quite similar to that of what we have in territory diesel. And if you're watching this video and you do not own a territory diesel SC or even a Land Rover or any 2.7 liter diesel engine, or even if you don't have a diesel fuel system but you're still concerned about P0088 and P0087, I think that this by the end of this video you'll have quite a good idea of what this whole shebang is all about, and what your next course of action can be. So to start this video, I'll just go through what kind of role a fuel filter is going to play in the overall this code thingy. You can have a code because of a fuel filter, whether and it can be 0087 and 88, regardless of the two extremities of a fuel pressure system. The what is too low and too high, but still the issue can be because it can be the fuel filter itself. After that, I'll just go through the fuel lines and carry the fuels around in this closed loop fuel system for territory diesel. And in the end, I'll discuss high pressure fuel pump, and then we will come back at what causes are there, what can be the possible causes for a too high fuel pressure, or too low fuel pressure, and how we can rectify it. And once we have gone through all of this, we will have a better understanding of that why it is triggering and what role each of these individual items play in this fuel system, and how to rectify it. First off, we will start with the fuel filter. So this is a basic fuel filter. If you look at it, this is just a part number of the fuel filter if you buy it from Ford. So Ford says that use the genuine Ford fuel filters because they come with a bimetallic valve. So we look into it what it is. So if you look at it, the filter itself, it's a housing, and there are some parts that are installed in it. So if we look at the housing itself, the filter that's in there, the cartridge itself, it's about an inch above the body, and that is that if there is any water that gets accumulated, so since water as a part of filtration, it actually settles down at the bottom since it is a denser than diesel. So denser diesel, since it is lighter, it goes toward the top and goes through the exit port, and water gets drained out at the bottom. It gets accumulated, and when it reaches a specific level, the water level sensor that goes in there at the bottom, it triggers an alarm that which is called the water and diesel alarm. So once it triggers that, the driver knows that the diesel filter needs to be either emptied or need to be changed. So this filter actually comes with 4 ports. We'll look into these 4 ports, what functions they perform. But first have a look at the internals of the filter. So if we look at internal, we'll see that there is a cartridge, just like any other filtrage. The concept is essentially the same. This cartridge is usually glued to a top section of plastic housing. Not a housing, it's a plastic base with a tube that goes in the middle of the filter. For now, we'll just call it the maze or fuel pathway. So the important part is that this plastic housing is actually it has a kind of a balcony structure at the side so that the fuel can seep out of it. So the fuel, when it comes from the fuel tank, it is actually dropped on the top, and from there it oozes out of the sides and goes towards the outer edge of the filter. And then it is sucked in, or with the pressure, it is pushed inwards, and from inside it goes up this tube and then goes through the exit port of the fuel filter. So let's have a better look at it. So let's just look at this fuel maze for a second, the maze or fuel pathway for a second. So the next view I'm going to show you is the top view of this thing. So if you look at them from the top, we will look at, we'll see 4 different ports that are on top of this thing. There's a metallic housing too. So let's have a look at this one first. So there is a metallic housing. It has 4 ports. So one of these ports, this one is the arrow indicate this is for fuel inlet, and this arrow port means that this is fuel exit. So the fuel comes from the fuel tank here, and it exits from here. Similarly, this port is just a air or fuel bleed valve. Not a valve, it's just a port where you can the air and fuel can bleed towards the fuel tank. And this is the return valve. So the return port. So the fuel from the high pressure fuel pump comes into this port. So this is actually the internal of, if you remove this cap or cut this cap out, you will see this thing where you can see that the cartridge is actually attached to the top of this fuel maze. The reason I call it maze is because, I mean, probably yeah, when you understand the function, you will realize the fuel has to follow a certain path. So you can see the balcony here where the fuel one comes in. If you look at it, this is the this is the fuel inlet port. So it settles right over here, and similarly, this return port settles over here, over this thing. And this is the exit towards the high pressure fuel pump. It sits over here, and this bleed valve, it sits on top of this division between these two portions of the fuel filter. And this is the maze. So the fuel actually comes from this fuel inlet, and it goes through the metallic strip, and then it slips past this balcony onto towards this towards this cartridge, so that it can actually be filtered. So if you look at the top structure, this is again the same thing which you just discussed. The only thing is that there is a recirculation valve. So the strip that we have here, this thing, it's actually called a recirculation valve, or a bimetallic. It's essentially a bimetallic valve with a ball valve. And what it does is that when it's cold, if you look at it, you can see that there's a notch at the end. So usually in default or cold position, this is pressed all the way up. So there's a ball at the top, this one. So when the ball is pressed upwards, any fluid or any diesel that comes in here will find a way to go past this valve. So when the diesel heats up above 50 degrees, this valve is closed. This is a bimetallic strip. It actually bends downwards, and the ball is seated on its seat. And that way the fuel will not be able to enter into the filter housing. So this is just for the return fuel only. It's not for the main fuel coming from the tank. So the reason it does this is that it's actually a clever way of doing this. So what happens is that when the fuel comes in here from this fuel tank, it drops in here in this housing, and then it goes through this metallic strip under the return valve. So if the combined temperature from the fuel coming from the tank and the fuel coming from the high pressure fuel pump is, greater than 50 degrees, the fuel will directly go through there. There will be no fuel coming from the high pressure fuel pump. If it's less than 50 degrees, there will be a partial open. It will be partially open. But if it's less than 30 degrees, the combined temperature of both the fuel coming from the high pressure fuel pump and from the fuel tank, in that case, this valve will be fully open, and the fuel and the high temperature fuel coming from the high pressure fuel pump will actually warm up the fuel that's coming from the water tank. So this is a way of actually preventing the fuel filter from waxing up, and making sure that the flow of diesel is significant, so that it actually can pass through the fuel filter with ease. So okay, so let's go back to the flow now. So this is how the flow in the fuel filter works, which I just discussed. That when it comes from the fuel tank, the red arrow is the fuel coming from the fuel tank, and the blue arrow is coming from the high pressure fuel pump. So below 50 degrees, both these ports are open, and fuel from both these ports will be coming in, going down the cartridge, getting filtered up, and then via this green port it will exit towards the high pressure fuel pump. So this pink port, which is the bleed port, you can see that you might have known already that this is you don't need any bleeding. It's a self-bleeding system. So this is how the self-bleeding works. So when let's just say that you have put on a new fuel filter, And how do you bleed it? You don't. You just switch on the ignition key for 45 seconds and do it multiple times. Every time you do it, the fuel will come from the fuel tank, enter here, and whatever the air bubbles are, some of the air bubbles and fuel will bleed out through this hole, while actually the rest of the fuel will go through this fuel filter, wet it properly, and start dumping in more and more fuel. And with the pressure, with the passage of time, the couple of few rotations of the key and ignition, what happens is that there will be a positive fuel pressure that will be built inside this fuel filter housing, and the only way out would be via this bleed port. So this is how this self-bleeding of this fuel filter works. Similarly, when the temperature goes above 50 degrees, then in that case, this valve is fully closed. The the bimetallic valve will no longer work, and the fuel will be directed. So, and the reason it doesn't work is because the fuel coming from the high pressure pump is actually hotter than 50 degrees, which means that now it needs cooling. So it is closed, and the fuel is diverted towards the cooler line. So if you look at actual installation of a fuel pump, you'll see that the fuel filter, you'll see that this line, this is the return line. So it is clipped onto the fuel filter with a T valve. So this is totally hollow, which means that even when the bimetallic valve is open, there is some quantity of fuel that might actually go through this particular route. But when it is closed above 50 degrees, each and all the fuel that returns from the high pressure pump goes to this line. So what is this line? This line actually goes to the fuel cooler, uh, which is mounted under the driver's seat under the body. So you can access it from under the body. So this is the line that goes towards the fuel cooler, and then uh, this line, the one above it, it comes from the fuel cooler. So there is another T valve. You can see that there is a wall line coming towards the T valve, and then the other line that is connected to the fuel filter. So the line that's coming towards the T valve, this is actually the line from the fuel tank. So you can have an idea that the input, the input or inlet fuel that's coming into the fuel filters come from two different sources. One source is via the fuel tank, and the other source is via the fuel cooler, which again comes from this uh, return line of the high pressure fuel pump. So essentially, it is a no return fuel system in which all the fuel will circulate inside the fuel filter till it gets consumed. The reason to design, there are a few reasons to design such a fuel system that I can think of. One of them is that it's less losses. Why do you need to pump so much fuel and put it all the way back and dump it back inside inside uh, the fuel tank? Secondly, the way it works is you essentially it brings all the gunk from the high pressure pump to inside the fuel filter, which means that you can look at the fuel filter, open it up, and see if you can find any metallic parts. If you find metallic parts, your fuel pump is probably gone or it's on its way out. It's kind of an evidence to that. Apart from that, it actually helps preventing the waxing, which is not really a problem in Australia, but in some colder climates, or probably in cold nights, it may be. So this again helps against it. It does create a few complications, and some of those are high pressure and low pressure uh, DTC cores. Yeah, but in some colder climates, or probably in cold nights, it may be. So this again helps against it. Is the high pressure fuel pump. It goes without saying that this is not how the internals of a Ford Territory fuel pump, high pressure fuel pump, or any other fuel pump would look like. It's just kind of a block diagram with emphasis on the volume control valve and the pressure control valve, so that we can see how these come into play when there is a fuel pressure problem that we have to diagnose. So this is this diagram actually shows how the condition of the volume control valve and the pressure control valve when the engine is switched off. The volume control valve will by default be closed, and the pressure control valve will by default be open. This actually ensures that when the engine is switched off, there is no residual pressure above atmospheric pressure in the even in the high pressure fuel line. So this is a good way of doing that. because usually you have to bleed out the system before opening up a rail or a high pressure line. But in this system, you don't have to, because you can see that this section after the high pressure fuel pump, when the high pressure is actually diverted to the rail sensors and the injectors. So when by default the PCB gets open when you switch off the engine, the high pressure from these rails actually backflows and bleeds out through to the return line from this section. So usually the fuel filter, when the fuel comes in, it goes to a portion of it is controlled by volume control valve and sent to uh, the high pressure pump, and most of it is actually returned via internal routing, internal pathways to the return line. This is a way of actually controlling the specific amount of fuel that can be pressurized. This actually reduces the overall temperature of the fuel that is inside the car, and because actually if all of it is get compressed by the high pressure fuel pump, then it will be returned to the fuel tank, and it will keep on circulating, and it will raise the temperature of the overall fuel. So we'll have probably an excess need of we'll have a need of an excess cooling for the fuel before it goes to the fuel tank. But in this case, the PCM controls the specific amount of fuel that is required by the engine, so only that gets compressed, and the rest of it actually goes to the return line. So a couple of words on the pressure control valve and volume control valve. In Ford territory, both these valves are located on the high pressure fuel pump itself, but generally these pressure control valves are found somewhere near the um, fuel rails or injectors, or diversion between or somewhere between the fuel rails and the return lines. While the volume control valves, there are also suction control valves. So they're called suction control valves because if the high pressure pump is operational, then it can actually suck the amount of fuel that it needs, and so you can actually say that, yeah, if you even if you don't have your center pump or low pressure fuel pump working, and this whole fuel system is already primed, then in that case, the amount of fuel that's needed by the engine can be actually sucked in by the high pressure fuel pump. But usually what happens is that um, in case of in case of heavy load requirement, this actually fails, and you get a code for P0087 because it's unable to match up the engine requirement. So there is a need for a center pump. uh, so let's see how now this works when the engine is started and it's idling. So at the engine idling, what happens is that the volume control valve is opened up to 30% by PCM, and the pressure control valve is closed by 11%. So these duty cycles are valid for a Ford Territory diesel when it's idling, and so the rail pressure is usually around 25 to 30 megapascals. If the PCM detects that on idling the rail pressure is increasing, so what it'll do is that it'll open up this PCB more. It will lower it to about 10% and 8% and 9%. So when it touches 7%, what will happen is that it will throw out a code for P0088, because it is detecting that no matter how lower the duty cycle is on the pressure control valve, the PCM is still detecting a high pressure from the pressure rail sensor. When it gets to about 7%, it throws that code, and then it commands the volume control valve to open by 15%, not 30%. So by doing that, it actually controls the amount of fuel that gets into uh, the high pressure fuel pump. The less amount of fuel that gets in, the less amount of fuel that gets compressed, and the less the overall pressure would be on the fuel rails. So this is how the PCM runs the strategy of fuel pressure control. It looks into the inputs. One of the critical input is the fuel rail pressure sensor. So the pressure comes from that sensor, and pressure comes from that sensor, and the control is exhibited by the PCM by changing the values on the volume control valve and the pressure control valve. Now we get to the Ford territory diesel's fuel pressure system. So we've already gone through the workings of a fuel filter and the high pressure fuel pump. So I'll just start with the fuel tank, then how the flow of this fuel works. So we have a fuel sender in the fuel tank. When we switch on the ignition, it's an electric sender, so it will pump the fuel from the tank to the fuel filter. So there is a single line that is joined by the fuel cooler line. We'll come back to it later on. So this red arrow then goes uh, into the fuel filter housing. We've already gone through the structure of the fuel filter. So through the cartridge, it passes on with the pressure that's been exerted by the fuel tank and by the residual pressure of the fuel filter. The fuel gets filtered, and then this green line is now the outlet from the fuel filter, and then it goes straight to the high pressure fuel pump. So the high pressure fuel pump returns some of the fuel which is unused or uncompressed, and the fuel that has been pressurized, it goes to the fuel rail injectors. So there are two rails, the left rail and the right rail. So if you're looking from the front of the car, so the right one is the injectors on the right side is called the rail one, or the left hand side. Yeah. So from the two perspective, you have to sit inside the car, and the one on your left would be the bank one, and one on the right would be bank two. The one on left would be called as the left hand bank, and the one on the right would be called as the right hand bank. So there's a fuel pressure sensor that's been that's at the attached at the end of the left hand fuel rail. So whatever fuel that goes into it, the sensor senses the pressure of it and sends this data to the PCM. So the PCM looks at the readings from the fuel pressure sensor and changes the values on the fuel pressure control valve and the volume control valve accordingly. So there is some fuel that gets leaked back through the injectors due to their working mechanism and lubrication. So there is a bit of leak back that's desired. So that leak back joins together and then goes and connects to the high pressure fuel pump return line. So now this whole return fuel, which is actually a bit hot, uh, actually goes to the fuel filter again. As we discussed, that there is an internal diverter over here in the fuel filter. So if it's less than 50 degrees, it's partially open. If it's less than 30 degrees, it's totally open, so that any wax that's been accumulated in a cold season or cold weather, that gets the filter gets dewaxed, and the flow of the diesel is a bit easier in the overall system. So it will go down, and then again it will move out and go towards the high pressure fuel pump. So this is how we call it a closed loop fuel system. So for some reason, if the high pressure fuel pump is failing and we have some metallic particles with the flow of with the flow of the fuel, then they'll also be trapped in the filter. And yes, that's why the techs usually open the fuel filter to see whether it's contaminated. And if they found those metallic smokes, then your high pressure fuel pump is a toast. So the other lines, when when the diverter or the bimetallic valve is closed, there will be no way of moving the fuel into it. If it's above than 50 degrees, then the fuel will directly go towards the fuel cooler. So after this fuel cooler is not air cooled. In fact, it is coolant cooled. So there are two pipes of coolants attached to it. So once this fuel is cooled or passes through the cooler, it goes back and joins the uh, inlet line for the fuel, and the last line that remains is this bleeding line. So the way this bleeding line works is that, even let's just say that we have installed a new high pressure fuel pump, a fuel filter, a fuel cooler, or anything in the fuel system. This bleeding line helps to remove the air bubbles out of the system so that you don't have to bleed it. So yeah, you can have a look at and think of all the routes this fuel is going to take, and any bubbles that will eventually come into the fuel filter will be removed by this return line. So this return line starts from the fuel filter, ends on the fuel tank, and even if you open it and attach a pipe to it, when the car is normally running, you will see a bit of fuel coming out of it. So it's not primarily designed to take the fuel back to the fuel pump. It's just there so that any residual air that's trapped in the system can be removed and purged from the whole fuel system. So now we are at the last leg of this video, where we'll go through the probable causes of the high pressure code and the low pressure code. We'll go through each of these causes, and then we'll see how it fits in the grand scheme of things. Now that we have discussed fuel filter, the high pressure fuel system, and the high pressure pump itself, you'll have a better idea of why uh, we are getting a particular code and what can be a probable reason for it. So let's just start with the P0088, or that is a fuel system pressure too high code. So the first probable cause is clogged fuel filter and blocked return line. So why would it exhibit itself? Why would a blocked line, a kinked line, would end up causing this particular error, that is the fuel system too high? To do that, first of all, we have to look at the fuel system itself. Let's just revisit it. We know that the fuel pressure lines, return line starts from the high pressure fuel pump. It is joined by the leak bag from the injectors, and then it goes towards the fuel filter. Now, let's keep this picture in mind and go back to the fuel pump itself. Let's just say that this is the return line. Now, you know that return line is a kind of a leak back from the high pressure. So when the pressure control valve, in this one, the pressure control valve, if leaks a specific and measured amount of pressure back into the return line based on what the PCM the PCM instruction is. So if you for a second think that there is a blockage here, this portion is totally blocked, or as we know that the line goes to the fuel filter. So if the fuel filter is clogged, if for some reason the fuel cannot go through this line, so what will happen is that the fuel pressure that's being leaked onto the return line, since it's blocked, just like, for example, if you're doing your dishes and the drain pipe is blocked, so the water has nowhere to go. Similarly, the fuel will have nowhere to go once the return line is kinked or it's blocked. So what will happen is that the fuel, since due to the absence of any drainage over here, there is no longer a lower pressure available on the return line. The pressure will start mounting up, and after a few seconds, or it's just a matter of time, when even no matter how much this pressure control valve is open, you'll still end up with a high pressure system reading on the fuel pressure sensor, because the fuel pressure sensor will be reading up the pressure that's in this line, right? But since this line is building up pressure, and this PCV is trying to open up and lose that pressure to the return line, but it cannot lose it because it's kinked, it's blocked. So what will happen is that you'll get up a P0088 for, I mean, it can be one of the reasons that a fuel filter that's been blocked or choked. For example, here, if you look at this one, so yeah, so if the fuel tries to come in here, and if it is clogged, it has nowhere to go up back again. So it'll exhibit the similar symptoms as that of a blocked line, because in this one, you just stop it from there, the pressure break flows and build on top of, and this fuel pressure sensor will sensor it, will sense it and send it to the PCM. So anything that blocks this return line, the PCM will sense it through the fuel pressure sensor, and it will generate this code, that's P0088. The second cause is faulty fuel pressure sensor. So, I mean, this is quite obvious. If the guy responsible for telling the operational conditions of the fuel system, if it's faulty, I mean, it will, the places will be all over the place. But there's another part of it. So usually there are other associated codes with P0088. For example, fuel pressure sensor value out of range, or performance values, or open circuit or short circuit, uh, scores on these lines. So if you have those codes on these lines, then just replace the fuel pressure sensor. You do not have to, diagnose as a faulty pressure sensor just because there is a P0088. And I mean, I've made the same mistake. I mean, I took this P0088 and thought my pressure my pressure sensor was faulty. So I won't be surprised if anyone else make the same mistake. So it's usually these sensors are robust. So make sure that you are reading correctly. For territory drizzle, I can tell you that if the system is idling, it should be at the idle. The fuel pressure system should be between 25 to 30 megapascal. Anything above it, or way above it, will probably identify or point out to a faulty rail pressure sensor. But apart from that, it's usually not the cause. It can be, but I mean, it's one of those causes. So you have to really put your head into before replacing a sensor just because you get a code. I mean, okay. The next one is faulty volume control valve. So let's have a look at the faulty volume control valve. So let's just say that this valve control is actually a solenoid which actually goes up and down and closes the pathways as PCM instructs it. So if it's faulty, what will happen is that maybe it's sticking. So PCM will ask us to open 30%. Um, or probably, I mean, yeah, it's if it's sticking, probably if it's coming back down. For example, it was open to 60%, and when the fuel was highly demanded, like in high acceleration, and when the PCM commanded the volume control valve to go back to 30%, it actually stuck there. It could not get itself back to 30%. In that case, what will happen is that even though the PCM instruction will show it's 30% open, physically it will be 60% open. Yeah, you never know. So what will happen is that you'll end up more fuel going into the high pressure pump, more than what PCM actually wanted. That would result in a high pressure uh, reading on the fuel sensor, and in the end you'll get a code. Similarly, the next one is faulty pressure control valve. So same as volume control valve, if the PCM wanted to close the pressure valve by 7% or 9%, but it's open, and was again due to the wide throttle. Let's just see it's under pressure, or sorry, when the engine is demanding high fuel pressure, then the this pressure control valve would be somewhat like uh, 30% or 20%, depending on how much pressure fuel is needed. But when the PCM asks us to lower down the value to close it to idling value, and if it sticks, you'll end up with high pressures. So again, if you have a faulty volume control valve or pressure control valve, what Ford says is just replace the whole unit. These cannot be separately changed, but actually from Land Rover, we know that these valves are separately available in the market. You just have to hunt them out, and you have to take them to a diesel specialist to make sure that once you have replaced these valves, uh, they do not leak. And secondly, the flow test of the high pressure pump is good. So usually, yeah, long story short, you have to replace the whole pump volume control valve in PCV as a combo. That's what Ford says. But if you want to do it, you can do it separately too. The last one is faulty PCM. So apart from that, I can't think of any other reason that why there would be a high fuel pressure code. If each and everything is working out, the only thing that's left behind is PCM. But you need to double check before doing this. Just take your scanner, put it on another territory or another similar car, and see and compare the readings that you are getting on that particular car from specific circumstances and specific environmental conditions, and match it with what you have. And if things point out to a faulty PCM, then there you'll have it. A faulty PCM, what I can think of, would probably in idle, will ask the PCV to be open 100%, or closed, um, or a VCV to be open, I don't know, 50% or 70%. Some of this maybe you can fix it by reflashing it, but in some cases you may need to replace the PCM itself. Now let's go to the 0087 causes, or the low fuel pressure causes. Again, the clock fuel filter is again a big item in here, which can cause the same error code, the 087 code, just like in case of 088. So why a clock fuel filter would cause this code? Because you can see that the only input toward the high pressure fuel pump is coming from the fuel filter. So if it is clogged, there won't be any pressure coming toward the high pressure fuel pump, which means that even with 30% open on idle, the volume control valve will be letting in less fuel towards the high pressure. So less fuel from what? From what PCM anticipates, because all these values have been mapped and PCM has an internal map of what's happening. So PCM will end up with diagnosing it as a low pressure, because even with 30% open BCV and 11% closed BCV, it's still not getting its 25 to 30 megapascal. So what's happening probably is just a low fuel pressure code. The second one is faulty fuel sender unit. This is in fact a very common fault in territories diesel. If your center pump is failing, or if the center pump has failed, you will not have much pressure or enough pressure to push your fuel through the cartridge into the high pressure fuel pump intake. Usually, if this thing fails, HPF or high pressure fuel pumps still have enough suction power to pull the fuel from the tank and pull it through the fuel filter. But when it's oiling under high load, it won't do the same and will throw a low pressure fuel code. Because of the same reason, it will not have anticipated amount of fuel going in. Now, this is a bit interesting. I was looking at one of the Navara videos, and the guy mentioned that it never came with a fuel tank. So what they did was they end up putting additional external fuel senders outside the fuel tanks to help in aging high pressure fuel pump to, facilitate its suction where it's failing now. But in territory, that's different. Territory, we have the low pressure fuel pump and senders. The next one is again a faulty volume control and pressure control valves. For example, if we end up with uh, in a scenario where we have some dirt coming from the fuel pump, it may uh, block some of the screens or portions of this volume control valve and pressure control valve. And with these values, 30% open, the amount of fuel will be less going in because it's partially choked. Similarly, same happens over there. If it's choked, and there will be less pressure going out as well. But it's not really onto the pressure control valve as far as the low pressure is concerned. But it can be, because if you have this uh, fuel going towards the fuel rail sensor, and if it is open more than, if it is probably used for a long time, and if it is this abrasion effect might have taken some of the chunk off of the cylinder pistons or the ball which actually is in there, then it will let more fuel go into the return line than what PCM would have wanted, and this would have caused the same code 0087. Uh, Faulty high pressure fuel pump, yeah, if it can be a good reason, because with the passage of time, if each and everything is good, it's still a metallic device which wears and tears, and with the usual, I mean, uh, with its normal usage, it is prone to failing after time. I'm not sure what the life limit that is, but it should run for a long time before it fails, but it can be a reason that the high pressure fuel pump is no longer able to provide pressurized fuel to the fuel system. Uh, Faulty injector with excessive leak back. So we do know from our fuel diagram that fuel rails have fuel injectors on them, and fuel injector uses a leak back mechanism to lubricate themselves, and that leak back is then connected back to the return line. So if an injector has failed or the seals in there is gone, then in that case it will leak more than the required amount of fuel which is designed. So what will happen is that instead of using that excessive fuel to keep the engine running, it will leak most of the fuel back into the leak back lines, and you will lose pressure which the PCM hasn't accounted for by excessive leak bulk from injectors. So you need to change injectors and that first, but you have to do a leak back test first. And the last one is again a faulty PCM. Any values that are out of normal, and if you have ruled out each and everything, I don't think that there is any other reason that can contribute to 0087 apart from the faulty PCM. And that concludes my video for today. And I hope you guys liked it. And if you can think of any other reason or possible cause uh, for 0088 and 0087, which I haven't identified, please do let me know so that I can add it or as part of my next iteration to the video editing. Thank you.